All over our body we have blood vessels, and in those blood vessels we've talked about how we have lots of different kinds of blood cells. So we have some red blood cells that I'm drawing here. But if you watched our immune system videos, you also know that we have some T cells and some B cells and some macrophages and some platelets. And all in all, actually, there's pretty much 10 different kinds of blood cells that we have in our blood at all times. In this video, I'd like to talk a little bit about where they're made, which you might already know, and also from what precursor cells they're made. Because cells don't just come out of nowhere, they come from precursor cells that divide and produce new ones. So do you know where all these cells come from, where they're made? I'm going to draw the answer. Cartoonish as always, and not to scale with this blood vessel. So here's a bone, and the answer is that all these cells come from the bone marrow, which is inside the bone here. Now when I first heard this, I thought to myself, how is it possible that blood cells come from inside the bone, get through the surface of the bone, and get into blood vessels? Well, you might be surprised to know that all these bones are actually perfused with blood vessels themselves. They're just very small and difficult to see. So it's actually quite easy for cells to hop into these blood vessels and go into blood vessels of the body. But now let's talk about those precursor cells. So it turns out, and this is something that we didn't know for a long time, but it turns out that there's one powerful stem cell in your bone marrow that can make all 10 kinds of blood cells. And that one cell, that very powerful cell, has a bit of a complicated name, which we'll write out here. It's called a pluripotent. Pluripotent. If you're good with your Latin, you know that this means, I guess, able to do a lot of things. That might be a poor translation, but anyway, pluripotent hematopoietic, because hematopoiesis is the process of producing blood cells. So that's pluripotent hematopoietic stem cell, because stem cells, as you may know, are cells that can divide into multiple different kinds of cells. And now I'd like to ask you a question, which is, do you think that a macrophage, which if you watch the immunology videos you know is a big phagocytic cell, so it likes to swallow invaders or debris, do you think that the macrophage is more closely related to a B cell, which as you know produces antibodies, or a red blood cell? You might be surprised by the answer. The answer is actually the macrophage is more closely related to the red blood cell, which is kind of weird because macrophages and B cells are both immune cells and red blood cells are not. This pluripotent hematopoietic stem cell gives rise to two main lineages, and I'll draw them here. The first is the myeloid lineage, and the other is the lymphoid lineage. So when this pluripotent cell here first divides, it can give rise to one of these or one of these. And these are also precursor cells to the 10 kinds of red blood cells that we actually find in our blood. So these are not the ones that are going to end up in our blood. These are guys who sit in the bone marrow and make the cells that end up in our blood. So now it turns out that this lymphoid progenitor cell can make actually 3 different kinds of immune cells in our body. It makes an NK cell, it makes a B cell, and it can make a T cell. And this is 3 out of our 10 blood cells that we talked about, and so the other 7 are going to be from the myeloid lineage. And one of those is, as you could have guessed, the red blood cell. Another is the megakaryocyte, which you may not remember what it does, so I'll tell you in a moment, but try to remember. The megakaryocyte is actually what makes platelets. So the megakaryocyte buds off little pieces of its cytoplasm surrounded by membrane, and these are platelets. But the myeloid lineage also makes a bunch of immune cells in addition to the red blood cells and the platelets. And you may not have heard of these, so I'll just list them here. One of them is the neutrophil. That one you're most likely to have heard of. And there's two other cells which are very similar to the neutrophil. One is called the basophil, and one is called the eosinophil. And don't feel too bad about not having heard about these because they're actually pretty rare in your blood. They are there, but there aren't many of them. And then there's also a monocyte, which is fairly similar to these three above. And the monocyte is actually what becomes a macrophage later on. You're probably familiar with macrophage. Monocyte is just a slightly less differentiated version of a macrophage. And finally, there's also mast cells. And mast cells are the ones that... So these are our 7 other cells. And as you can see, what we said in the very beginning is in fact true. The red blood cell is more closely related to the monocyte or the macrophage than is a B cell or a T cell or something like that. And now I'm adding an addendum to this video to mention one other kind of cell that we've talked about in the past videos but that I didn't put on this chart. And that kind of cell is the dendritic cell. It's one of the antigen-presenting cells that we talked about. And I want to ask you, do you think the dendritic cell comes from the myeloid lineage or the lymphoid lineage? And it's actually a trick question because the answer is it comes from both. So we have some dendritic cells that I'm drawing here, which come from the myeloid lineage, and some, which I'm drawing right next to it, which come from the lymphoid lineage. And it turns out that the ones that come from the myeloid lineage are created from monocytes, whereas the ones which come from the lymphoid lineage are not really descendants of B or T cells. They come from some lymphoid precursor. So dendritic cells are kind of a weird exception. They can be made from either line. And I wanted to add yet another piece of information, hopefully not overloading this too much, just to remind you once again that monocytes, in addition to becoming dendritic cells, can also become macrophages. And macrophages we are certainly familiar with, at least we've talked about them in the other videos. So here's a macrophage. And macrophages, if you remember, are kind of like sentinels. They sit out in the tissues and watch for invaders. And dendritic cells also behave like that. So what about this monocyte? Does he do the same thing? Well, actually no. It turns out the monocyte is kind of like a circulating version of macrophages or dendritic cells. So what do I mean by circulating? I mean that it's actually in the blood. So monocytes move around in the blood, and then when they go into the tissues to settle down and become sentinels, that's when they are turned into either macrophages or dendritic cells.